The global battery industry built its foundation on lithium, a metal concentrated in a handful of countries, extracted from ecologically sensitive regions, and subject to extreme price volatility. Sodium ion technology represents a structural departure from that dependency. The driving force is not performance, it is geography, abundance, and economic resilience. Lithium, cobalt, and nickel, the three critical minerals underpinning modern high energy batteries, share a common vulnerability: concentrated supply chains. Mining operations for these materials carry documented geopolitical risks and environmental costs, particularly in the ecologically sensitive regions of South America's Lithium Triangle and Central Africa. Lithium carbonate prices peaked at over 600,000 yuan per ton during a recent supply shock, triggering a massive acceleration in sodium ion research and development globally. That price event exposed the structural fragility of a battery industry anchored to a single carrier chemistry. Sodium is the sixth most abundant element in the Earth's crust. It distributes across every inhabited continent. It sources from common sea salt or mined sodium carbonate known industrially as soda ash at approximately $0.05 per kilogram, according to industry material cost assessments. That cost structure creates a permanent pricing floor advantage over lithium. Where lithium carbonate prices fluctuate with mining output, geopolitical decisions, and speculative demand, sodium's feedstock cost remains stable by the nature of its abundance. Sodium ion also eliminates cobalt and nickel from certain cathode chemistries entirely, specifically Prussian blue, analog, and polyanionic formulations. The ethical and environmental liabilities attached to those minerals disappear with them. Manufacturers, including CATL and BYD, have positioned sodium ion not as a replacement for lithium ion, but as a strategic complement, a parallel chemistry that allows production lines to switch based on mineral availability and market pricing. That flexibility functions as a supply chain hedge at industrial scale. Mass-produced sodium ion cells have reached a cost of approximately $70 per kilowatt hour. Industry projections, cited by battery market analysts, place parity with lithium iron phosphate, currently at $45 to $60 per kilowatt hour, achievable as sodium supply chains mature. Global tracked sodium ion cell production capacity has reached approximately 370 gigawatt hours, with China accounting for over 95% of both installed and announced capacity through the end of the decade. The IEA confirms sodium ion momentum is growing, while noting that supply chain scaling outside China remains a primary constraint on adoption speed. The economic and geographic case for sodium is structurally sound, but supply chain resilience alone does not determine whether a battery technology succeeds materials science does.